minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up. T minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up. T minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up. T minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up. T minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up.
Jupiter's magnetosphere is a large pocket of charged particles that's sitting inside the solar system. and it's comprised of both Jupiter's magnetic field and all of the charged particles like ions and oxygen and nitrogen and electrons that are all charged up and rotating around with that magnetosphere. The magnetosphere is actually quite large. It's about 50 Jovian radii or 100 Jovian radii across, which is quite substantial in the solar system. In fact, it's the largest object in the entire solar system. The sun's influence, the solar wind, stretches out the back end of the Jupiter's magnetosphere, and the tail reaches all the way to Saturn. The Cassini flyby offered us this unique opportunity to study Jupiter both from outside of the Jupiter's magnetosphere and inside. Cassini was flying past on the outside of Jupiter, in front of it, and we had Galileo inside Jupiter's magnetosphere orbiting Jupiter. And so we were able to make simultaneous measurements both within and outside the planet's magnetosphere. At the same time, we had the Hubble telescope viewing Jupiter to give us another view, as well as Chandra, which is an X-ray telescope. And we had radio telescopes around the world as well, an interferometer at the Very Large Array in Socorro, New Mexico, and the Deep Space Network, which has antennas that are mainly used for communications with the spacecraft, but also are used for scientific purposes. What basically happens is there's a big bow shock in front of Jupiter, much like that a boat's wake traveling through water very fast. And that bow shock moves out in front of Jupiter, and the sun is pushing pressure on it by the solar wind's influence. The charged particles flying off the sun are banging on the charged particles that Jupiter itself is emitting and containing inside of its magnetosphere. It's as if there's a little balloon filled with charged gas inside the solar system, and that balloon is Jupiter's, and it's filled with Jupiter's hot gas. And then the sun has its own hot gas, and it's blowing out in a giant wind, and it's banging against that bow shock. And what happens is as that pressure changes, the bow shock itself is moving back and forth, vibrating like this, oscillating back and forth and changing in direction slightly. Jupiter has radiation belts, not unlike the Earth. The Earth has radiation belts. We call them Van Allen's radiation belts. And Jupiter has these intense radiation belts, which are really just very high energy charged particles that are trapped in the magnetic field very close to Jupiter. And in fact, Jupiter's are much more intense than the Earth's, and probably the most intense radiation environment in the entire solar system. And so we used Cassini. In fact, we used the radar instrument in a listen-only mode called radiometer. And we mapped out those radiation belts looking at radio emission that was coming from very, very high energy electrons. What we used was the high-gain antenna, the big antenna that communicates with the Earth. We actually faced it at Jupiter. And to turn it, we actually had to turn the whole spacecraft. And so you had this big antenna, kind of shaped like your antenna that you would use to get direct TV or any kind of TV signals. It looks like a little dish. And we actually moved it back and forth across Jupiter in such a way as to slowly map out the entire planet. Jupiter's aurora is basically coming from its atmosphere, and it's a glowing ring of light. In addition to the ring of light coming from particles in the magnetosphere, the satellites of Jupiter, Io, Ganymede, Europa, and Callisto, all have footprints that can be seen glowing on the atmosphere. And these are footprints that are connecting the satellite with Jupiter's atmosphere. And these are connected by magnetic field lines.